Meeting to order. This is the meeting of the Ojai Groundwater Management Agency on January 29th at 3 o'clock. I'm going to call the roll.
Director Gilman?
Here.
Director Daddy?
Here.
Director Finch?
Here.
Director Weaver?
Here.
Chair Hages?
Here. Do you have an agenda copy for me?
Sure.
Thank you. Okay, let's stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with
Liberty and justice for all.
Okay, director's comments or announcements. Mike?
Well, we had so much rain over the holidays. I checked with the mutual water companies, and both Siete Robles and Hermitage just had blood in the streets, nothing serious. Senior Canyon, on the other hand, had some very difficult areas. You might have seen the article in the paper on we had a slide. The water came down a road that runs around the reservoir and then came down the east side of the dam. Fortunately, the dam was not damaged at all, but we've had a lot of visits by the State Department and Dams and engineering costs, and we were talking. We had another big slide at the entrance to our tunnel, and where we are in the midst of a $3 million grant to renovate that tunnel to hopefully what it was in 1929 when it was dug. But it was a rock slide and then took a big portion of the hillside where the road is. And so we're in the process of rebuilding that hillside. It's a costly venture.
Yeah.
To have to do this. So just let you know what's happening in the world of water.
Hey, thank you. Yeah, it's nice to get water, but not all at once.
Yeah.
Jim,
Nothing from Ojai Water Conservation District.
do you have a question, Bob?
No, I was gonna comment, it would have certainly helped down at our diversion unit, that high water.
Oh, yeah. Andy, do you have anything, City of Ventura? Bob, anything?
No, nothing from community.
I think we're nearly a half a foot from spill.
Yeah, a little less than 6 inches from spilling at Lake Casitas.
Okay, good. Okay, next is general manager comments.
So a few updates. We do have an active well application for a property on Mercer Avenue that DUDEC is in the process of evaluating, and that I'll try to bring that back to next month's meeting for your review. We have the 2-year audit underway, and I am trying to find some focus time to respond to all the requests for data and information, getting support from CC and the bookkeeper. Making another push to take care of some delinquent accounts who have not been reporting and have not been responsive. So some certified letters are going out, and I really want to make a push this year to get those delinquencies on the property tax rolls and follow through on that process by May. The state controller report is going to be due next week, so we're working on that. And as you know, DUDEC is working on the 5-year update to the groundwater sustainability plan, and I have biweekly meetings with them to stay on track and focus on that as well. That's all.
Okay, thank you. Okay, Jordan, basin report.
Thank you, Chair Hages. Share the screen here with the Zoom and the screens of the world. Okay, today's presentation, and pardon the missing tilde there, but it's La Nina versus the polar vortex. And when I envisioned this, there was a comic book cover with two fighting entities. And when I started searching for that, I realized that's probably not appropriate for a public forum. So, without further ado, those terms have been in the news quite a bit over the course of the fall and into the winter, as we've been anticipating this water year. And what we've been seeing on the ground, above the ground and below the ground, I find very interesting as we delve into that eternal battle between La Nina and the polar vortex. Locally here, we're well above average already for what would be a typical water year. Average rainfall on the valley floor is about 21.25 inches. Thus far to date, we're at 22.67 inches on the valley floor, and up on the ridgetop that collects much of the precipitation that is recharged to the valley at 43.62 inches. And that's just since October 1st, when the water year began. Now, what has that done directly to the subsurface? Right here is a frame grab of the graph of the water levels shown in blue in the Elrod well. The scale on the y-axis here is about 200 feet of elevation or depth, as the case may be, depending on one's perspective. And the x-axis is October 2023 through yesterday. And what does this all mean as far as taking in water to the subsurface? Let's look at what fell from the sky. In 2023 to 2024, on the valley floor, we had 28.86 inches of rain. Last year, the full water year, we had 9.21 inches of rain on the valley floor. And this year, to date, we're at 22.67. You might look at this graph and you might think, well, that's kind of odd. Look, we're at less water this year than we were 2023-24, but the hydrograph just shows a little blip in 2023 to 2024 with respect to water levels. In fact, that water level in that year from nadir to peak was 48.6 feet of rise in the water table at the Key Well. The drier year, 7.5 feet of rise in the Key Well. And this year, 75.77 feet as of yesterday and rising. So you think, gosh, I love working here because I feel like I learn something new every single day, every single month that we're studying this basin. And I look at this graph and I think, wow, we're double the amount of water level recharge or increase in elevation in the basin, but we're at 80% of the amount of precipitation we had in 2023, 2024. And I look at that and I think, gosh, this is just groundwater management at its finest, using it when it's there, accepting recharge when that storage capacity is available. But also we're seeing that rejected recharge or that supercharged condition in 2023, 2024, when the basin just couldn't take any more water, that it was spilling out, and it's spilling out today in a lot of places out of the perch system, but in the main basin, in the main production aquifers, we still have room to grow. We still have room for infiltration of creek and stream water as it enters the basin. We'll get more into that. Oh yeah, like the kid who missed his school yearbook photo, not pictured, 2022, 2023, 44.07 inches with a 158-foot rise. So that was a wetter year with a lot more rise. And it's that antecedent moisture and antecedent condition that disallowed more infiltration in 2023 to 2024. On the longer term hydrograph, the numbers that we've got so far, the depth to water in that Key Well as of yesterday, 66.60 feet, gives us about 90% capacity or 72,000 acre feet of water in the Ojai Basin. We are well above our spring high from 2025, which was 99.77 feet, and our November 5th, 2025 nadir of 142.37 feet. Putting those together, that's where you get that 70s feet of rise. On the surface water side, something that we've been monitoring frequently, Out of Gridley, Thatcher, 2.45, 4.77 CFS. Reeves Creek flowing in at 2.51 CFS. Surface flow out at Montgomery, or Fox Drain, 1.97 CFS. Surface flow out of San Antonio Creek proper, 6.69 CFS. Senior Canyon at Ladera Bridge, 9.53 CFS. McNell was dry, incidentally. Coming in at Stewart Canyon, just above the debris basin, 0.11 CFS. And all of these are, for the most part, over some alluvial stretch of creek. So the inflow here is probably greater on the recharge side than what we're actually measuring as surface flow, as there is some subsurface flow in through these known and defined channels of each of the alluvial fingers that extend up into the mountains. The total that we measure, subaerially, 19.36 CFS. And on the discharge side, the outflow 18.66 CFS. So we're seeing probably well over 1 CFS net recharge, and much of that outflow is still coming from the perch system. Now, we look at the surface water pretty closely, and so do several other entities, the U.S. Geological Survey and the County of Ventura. And one of the gauges that we often look at are the gauges at San Antonio Creek at Camp Comfort. So it's just downstream of the Ojai Basin boundary, but still within the OBGMA jurisdiction. In fact, this is sort of the tail end of the OBGMA mapped jurisdiction. And I just reported that our outflow was around 19 CFS, and as of today, the automated gauge was reporting the observation of 198 CFS at that point, which is a factor of about 10 times what is actually flowing underneath that bridge. Now, that may or may not be trivial, but if someone is unfamiliar with this watershed and is perhaps in a town or a state or another side of the planet where...
Could somebody mute?
So if someone is not familiar with this watershed, they might look at this observation and think, wow, that's gospel. We've got 198 CFS flowing out of the Ojai Basin into San Antonio Creek, which is simply not the case. In fact, the modeled HPSF flows here are much more accurate. That orange line that's on this graph at about just under 25 CFS. Whereas the blue line that's reported as observed is the errant one at 198 CFS currently, and relatively horizontal over the course of the past week or so. So I think it's important. It really speaks to the value of day-to-day monitoring, observations on a weekly basis, et cetera, of stretches of the creek like this to anchor the management in the reality of what's flowing through the creek, as opposed to expecting what might be reported as observed, but is off by an order of magnitude. Now, when those gauges were installed, a lot of them were put there for flood observations and alerts of serious hazards, and for that, I think they do a pretty good job. In this case, the flow rates reached, into the thousands of CFS over the course of the storm flows that we had in late December and earliest January, but still receded relatively quickly owing to the flashy nature of the system. This is what that 2.51 CFS inflow at Reeves Creek looks like, and in the lower right-hand corner you'll see the yellow camera over the basin that indicates where approximately this photograph was taken yesterday. Gridley Canyon coming in 4.77 CFS inflow. Stewart Canyon, the least, 0.11 CFS. That's all of about 50 gallons per minute you see flowing through there, trickling through some of the cobbles. McNell Creek was dry where it enters the basin. It's a relatively small catchment. Thatcher Creek, cascading underneath McAndrew Road there, under the bridge, 2.45 CFS. And where we had 9.53 CFS, this is what it looked like about 2 months ago. whereas this is what it looks like today. So a lot of called out material, a lot of boulders that have moved around, and of course, a lot more water. At the confluence where San Antonio Creek officially begins, the confluence of Gridley and Senior Canyon, we have the dry road crossing that looks like a cascade. You'll notice how little vegetation and debris there is there. So much of that moved out in the high flows of late December. As you go further downstream, looking south on San Antonio Creek from Grand Avenue Bridge, see a flow that is contiguous all the way across the basin. Outflow at Montgomery, this is about 2 months ago, and much cleaner operation now. A lot of debris has been called out, just under 2 CFS at that bridge. And at the location where we monitor the outflow at San Antonio Creek proper, just at the basin boundary, as shown by the location of the yellow camera on the basin map inset. This was about 2 months ago, and about the same location today. Very little debris. It's all been washed away, except for that which you see piled up onto the left here, and of course significantly more flow in the creek. 18.66 CFS, that's what it looks like. Now the old Creek Road gauge that is down there closer to the confluence of San Antonio Creek and the Ventura River, I checked today, it showed about 2,100 CFS flowing in the creek there, but it's probably more like 20. And I think about why this might be wrong. Well, number one, I think the radar gauge is in the wrong spot. One, it's right over some dry sediment or drier sediment that is off just to the east of the creek, whereas you can see on the far right side of the creek here, or the west side of the channel, that's where the flow is actually present. But the radar gauge that informs that county gauge is off to the east where it's dry. And so it's recording or it's observing a LiDAR or radar type of measurement of an elevation of a dry sediment surface that is a much higher elevation than the water surface, in addition to the width. So if you're looking down from that gauge and you think that's water underneath you at that elevation and at that location, it's easy to see why one would calculate 2,100 CFS in that creek, right? Not the case. What do we got going forward? This may be accurate. The next drought may have already started, if we believe what NOAA has to say. Their seasonal precipitation outlook for February, March, and April 2026 is that we'll be below average to leaning below average of precipitation over the course of the coming quarter. Now, it's interesting that the forecasts that we shared in November and early December, before the rains, showed equal chances of average for this area. And we're just about above average so far. All right, so what does the polar vortex do? What does it mean? The polar vortex is, as shown in this graphic, it's a cold air, low pressure zone near the pole, near the North Pole. There's one at the South Pole too, so it's not just unipolar. It's something that does exist always and is of various intensity. And this year it seems to be pretty intense, coupled with La Nina, that warm air that's sitting near the equator and becomes colder during La Nina times in the sea surface temperatures, has an effect on the jet stream. And when that jet stream and the La Nina surface water moisture of the Eastern Pacific Ocean come together, that's when the jet stream starts taking an interesting and variable track. Compare that to El Nino. Didn't put him on the comic book cover, but there's really a variability to the Pacific jet stream in La Nina years. It's going to be thinner and colder typically than an El Nino type, and have a variance to Washington State down to Southern California, like we've seen this year. Remember the catastrophic flooding in Washington State from 2025. And then, of course, our very intense, relatively short-lived, highly variable storm systems that have come through this water year to Southern California. Compare that to the El Nino years when it's a much more consistent, less variable, but wider swath, almost exclusively on the southern side of the continental United States. whereas Washington State and the Pacific Northwest tends to be drier during those El Nino seasons. So, who wins in La Nina versus the polar vortex? I would say it's California. And you may have seen this graphic, but this is a drought monitor map indicative that California is the only state in the union, including Hawaii and Alaska and even Puerto Rico, that had zero indication of abnormally dry conditions or drought. That, of course, will change, but it's literally a once-in-a-lifetime event that I've seen this happen, where we have no indication of drought anywhere in California. And I noticed that they didn't write normal. They just wrote none, which kind of leads me to believe that's right. There's some recognition that, we're almost always going to expect some normalcy of drier conditions in Southern California. That's it.
Thanks, Jordan. Any questions?
I have a question. Jordan, we're still gonna be getting perk coming down out of the hills for a while,
Yes.
and we already have aquifer conditions,
The artesian conditions?
artesian,
Yeah, there are a couple of artesian wells. that
Boardman and
we're starting
Gridley
to see.
still, those are the main
Just
ones.
starting to see those. So we do expect that to continue. There is some capacity to still supercharge the basin ahead of us.
So looking at the numbers, are we full at 90%? Because anything else we put in, it's gonna run out the other side. Is 90% really?
Could be.
The
It
number.
could be. And part of it is that there is that supercharge capacity that still is a capacity to the basin. The water levels still can go up. And in thinking about it too, the perch system itself may encompass about 10% of the basin storage capacity. So that can be full. And if that's full, then the deeper stuff has nowhere to go if it goes around the horn in the recharge areas to supercharge that shallow aquifer system. So the usable storage capacity of the Ojai Basin, that for the management should probably be, like you say, yeah, about 90% and down to about 40%. The above and below status being something that can be for management.
Were we able to capture anything through our recharge basin, our little bunkers out there?
Yeah, my understanding is nothing was diverted. There's a small amount of catchment on the south side of Ladera Ridge that will naturally flow into those ponds and be slowed somewhat from their typical discharge to San Antonio Creek directly, but nothing that is managed and directly recharged.
So if I make this statement, please correct me. The recharge is gonna be irrelevant unless we have extremely high, fast flow, because it just won't get to it because it's just not positioned correctly. And if we do get recharge, it's something we're at capacity anyhow, so it's probably not a useful endeavor to even worry about, because we're gonna be at 90% and catch nothing. And if we don't catch anything, again, the relevancy there, so. It's like, we wasted a number of millions of dollars on something that's not functional, it appears. The watershed did.
In the blink of an eye that is 2026, yes, at this moment. The spreading grounds, as I understand it, was designed to capture stormwater flow at times when there is enough flow and is enough capacity in the basin to accept that recharge. It's not going to be all the time. There's going to be times when there's too much water in one or the other. One of the other problems of the system is that the way it's positioned, as you said, the diversion structure itself, the engineers designed it in such a way that it was placed to take gravity passive flow from the creek under a certain flow rate and at a certain elevation. But later storms culled out quite a bit of boulders and cobbles and sand from that, lowering the base elevation of the creek, such that we can have high enough flow in the creek to divert from a flow rate standpoint, let's say 200 CFS, but doesn't reach the threshold at which it will passively fall into the intake structure. So There is a lot of value in the San Antonio Creek spreading grounds. It still requires adaptive management, and it could still stand some changes, but it's a matter of optimizing that for reality and managing it in such a way that will be beneficial during the blinks of an eye, that we have the conditions of available storage capacity and adequate flow in the creek.
I'll make a comment on that. It can't work the way it is right now. You have to manually get to the other side of the creek. You have to be out there, and it silts in, and you can't desilt it at the times when it needs to be. The trouble is all at the inlet. It's all at the inlet. And until the inlet is fixed, it's useless.
And so is there a possibility of doing an upstream diversion, just like, we'll put a little channel there upstream where we can get diversion to go in because we've got the elevation upstream and we can compensate for the,
No.
for the flow level downstream?
I won't say yes or no to that. I just know that why it was done is the reason that those things aren't done anymore, to speak of. So I don't know. And who would do it?
The other problem is it has these fine screens that have to be cleaned because they plug up with debris.
And the silt behind them.
Yeah.
No, it will not work the way the inlet is today.
Any other questions?
Yeah, Richard, hi, everybody. This is Peter Candy.
Yes.
Jordan, when you're giving us your report, appreciate that. But in reference to these, this inaccurate data is a little bit concerning. I'm just wondering if there's, inaccurate data out there. Is there a potential that that gets misconstrued, misapplied by, folks in the context of, well, any number of things, but the groundwater adjudication, ongoing discussions with state authorities, that sort of thing. Is there a need to at least clarify or correct some of this data? I'm just wondering, because it was a little bit alarming to me to find out that there's, monitoring going on that isn't accurate.
That's an excellent question, Counselor. The idea of preliminary data being inaccurate is one long-standing in the scientific community. The county's websites from which we pull that information have a disclaimer asterisk that data are preliminary and may be subject to change, and of course they are. One of the problems is that that's the snapshot that a lot of people will see in making instantaneous management decisions about diversion or adding water or taking out water or what have you with respect to this hydrology. And it won't be until 2027 that my understanding is the county will issue a hydrology report that has those data corrected, which means that having that information out there without the full understanding that these are off by an order of magnitude or two, and enjoining a party or someone to say, thou shalt do X because of Y, and Y is off by an order of magnitude or two, it's something that is concerning. And I think it's great to see the audience we have here today in person, as well as online, that gives us hey, people are paying attention to this. And this is a significant question that needs to be addressed in a way that is going to have some teeth and legs. And I trust that it will. Even if it's just the county changing these more frequently, making them more accurate would be best, but either not showing those data or really making it very bold that those are preliminary.
But so it sounds like the county is aware. They know there's an issue, and when they issue a report, it'll be updated. And in the meantime, we need to be aware and careful of the fact that other folks, whoever they might be, might be grabbing this data and trying to make assumptions with regard to it. And And it just, we need to keep that in mind, it sounds.
Absolutely, well summarized.
Yeah, and you have to remember that in general, all of these gauges, their initial intent was flood control, to give warning for downstream communities. So they didn't really care about moderate flows during periods when it's not raining.
Chair?
I think that's changing. I mean, we're improving some of the instrumentation, but it's still not that accurate.
Chair, well, the county knows and we know. Do the courts know? And would it be prudent to send some of this information in? Adjudication's coming around the corner. And if they think there's 10 times as much water, it works either way. It's 10 times more than we have. And so those things can be skewed. And so if we have accurate information, I think it's something that we should get to the courts so they can have a basis when they start distributing the flows. Just a thought.
It's a known issue, so. Any other questions? Thank you, Jordan. Thank you. Okay, the next item is public comments. Does anyone have any comments on items that are not on today's agenda? Okay, hearing none. Item 7 is the consent agenda. That's the financial report for December 2025 and the minutes for the December 11th meeting. Any questions or comments on those? If not, can I have a motion to approve?
So
Motion to approve.
I'll
Any-
second.
Call the roll.
Director Gilman,
Yes.
Director Daddy.
Yes.
Director Finch,
Yes.
Director Weaver,
Yes.
Chair Hedges.
Yes. Okay, item number 9, discussion items, legislative ad hoc committee updates. Anything on that?
There was no ad hoc committee meeting since our last board meeting. I did want to give an update on the Small GSA Coalition. We had a call a couple weeks ago, and they are working with DWR staff on that Prop 4 allotment for small GSAs to kind of streamline the grant process and make it flexible for small GSAs. So I think there is a good chance that we'll be able to submit an application to get some help on preparing our 5-year update out of that grant.
And at this point, do you know how many committed?
I believe there were 11 committed.
And it would took 6 to make it
Yeah,
go?
it's going.
it's
I
going.
think the only one I heard that dropped out was Montecito Water District.
You're broke.
No comment.
You're safer.
Yes. Okay, the meter compliance committee, I don't think we have anything on that. And
No.
then Julia, you were gonna give us a presentation on the basis for selecting our basin?
Yeah, let me see if this is gonna share. Okay. So at the last meeting, we talked about the basin prioritization process, and I went through this document, which is, I got from DWR. I know there's a DWR rep on the call. It's basically the process that they went through to prioritize basins, the procedure that they went through, all the criteria that they considered. This was as of May 2020. I'm going to go through all of that. I am not an expert on this subject because it looks like there was a lot of work put into it, and I gleaned out what I could to make it not a dry presentation, hopefully. So stop me anytime if you have questions. I think it will shed a lot of light on how the Ojai Basin was categorized as a high priority basin and the factors that went into it. So we'll go through all of the different components and how the basin ended up. This was basically the mission statement for the SGMA, that the groundwater resources of the state be managed sustainably for long-term reliability and multiple benefits for current and future beneficial uses. There's the kind of legislative background. The Sustainable Groundwater Management Act was passed in 2014. An update to Bulletin 118 was done in 2016. And then the basin prioritization process started in 2019. There are 8 different components that were looked at to determine a basin's priority. I'm going to walk through each of them, and you'll see where Ojai scored on each of these components. I don't have a lot of the background documents that went into it, but I do have the spreadsheet with all of the components and how Ojai ranked. So we'll go through each one. Some are easier than others. Some we'll breeze through, other ones take a little bit more explanation. So the first one was population density. They had to use 2010 census population blocks because the 2020 census hadn't been completed yet. The density was basically the total population divided by the square miles, the area of the basin. So the population from the 2010 census was 7,745 divided by the 9.24 square miles, gave a population density of 838. And then the table that they use, every one of these components has a table, and depending on what your number is, that gives you your priority points. So because our density was 838 people per square mile, we fell into that third row, of X being between 250 and 1,000. So we get priority points of 2 for that component. Okay, and it's going to be similar as we go through these. There'll be a table and a points that we get. Then they looked at the rate of current and projected population growth. There's the whole spiel on the data sources and how it was calculated using the, census block data, Department of Finance data, county population estimates from the California Water Plan, and then all the calculations that were used to do a projection. So any guesses on what you think the percentage of population change is going to be?
-1. Negative. Yeah.
Negative 12.7. So you're all on the right track. So we got 0 points for population. That was one thing that I thought was significant, actually. 12.7% was much higher than I thought. I thought it would be a single digit. But that was their methodology, and that was the number that they came up with. So 0 points for projected population growth. The next component was public supply well density. So that's the number of public supply wells divided by the basin area. They identified 8 public supply wells. Again, this is from publicly available information, the DDW's public supply database, and then verifying it by locations and through their public comment process. So 8 public supply wells, again, divided by the area of 9.24 square miles, put us at 0.86. So that gave a points of 4 for that factor. So a little high, actually, on the population density in terms of that table. Do you have a question, Bob?
That's well density, not population. We're talking about Siete Roble.
This is well density.
Yeah, we're talking about Siete Roble, which is very small,
So
and Senior Canyon. Right?
When I see the number 8, I think that's just the Casitas wells. When you're talking about, and it would actually make the number higher if we added those other wells. So that would have given us more points. Right?
No, you'd be
I'm sorry.
by a higher number.
It would be a higher numerator.
Yeah.
So the density would have been.
And so why aren't those in here? You do have those communities.
They didn't. I don't know why they weren't considered public wells.
Could we challenge that?
I have to. There might be other things that you want to get into with this,
The whole thing
and
first.
that might be one. Then production well density was another component. So this is all the wells, all the agricultural privately owned wells. There were 164, again, divided by the area, gave a density of 17.74 production wells per square mile. And on the table, that yields a priority point of 4 for production wells.
And size of well doesn't.
Production
not
well.
matter.
It didn't, no, it didn't factor in, just the number. There's a little more detail. You could say, were they active, inactive? Like I said, I don't have all the backup with like the actual list of wells. I'm sure DWR has all of that backup, but I did not request it.
And Drysdale Farm over on the way over to Fresno probably pumps more water out of their one plot than we do in the entire valley in a decade.
The next factor was irrigated acreage density. So they looked at statewide crop mapping that DWR has. They looked at land use information, and they took the total irrigated acreage and divided that by the basin area again, yielding an irrigated acreage density of 205.2 acres per square mile. And again, that lands us under the higher, 4 for priority points. There is a lot of irrigated acreage in our basin. That's, not a surprise.
And that's 2014.
2014, yes. That was the data they had at the time. Okay, then this one has a few steps. The degree to which groundwater is relied upon as a primary source of water. So part A is just the total estimated groundwater use. They looked again at the data for evapotranspiration in their applied water model, statewide crop mapping, used the irrigated acres, water balance data developed for the California Water Plan, and then this public comment part pops up a lot. I wasn't involved at the time, so I'm not sure what that public comment process was. And then they determined the total acres of each major crop, determined an applied water amount for each major crop, and then the total water applied for each crop between surface water and groundwater, and then calculated the total groundwater use. And this one was a pretty decent number that I thought. In the Ojai Valley, about 6,600 acre feet of groundwater was for ag, and 1,132 was for urban use. And they divided the total water, 7,730, by the number of acres instead of square miles, and you end up with 1.3 acre feet per acre. That doesn't seem like an unreasonable number to me to apply to a crop, right? It's 1, 2, maybe sometimes 3. I think that's a pretty reasonable number. But again, you see on the table, that puts us in the higher category for priority points, the maximum of 5 points.
Julia, can you go back to that slide? This is Peter again.
This one?
Yeah, I mean, that seems out of touch with what the total bumping from the basin is on an average annual basis.
I agree, that 7,730 number.
But isn't this groundwater, the previous thing said groundwater and
Urban.
surface.
I thought it said ag and urban.
Well, Casitas serves ag
And
water.
that's the thing, is the casitas portion, I think, is in here.
I agree. I think it's not just basin water.
That's total water use.
Total
in
Yeah.
the 5,914 acres of the alluvial basin area.
Right, because that
Groundwater
doesn't
or
tie to
surface
their
water.
previous.
Yes.
Their previous thing was, which would have made it worse.
Well, it seems to me that this, what they're looking at and what they've got wrong is the amount of groundwater that's pumped out of the basin, right? If Casitas water is included, it's not the degree to which groundwater, but it's the degree to which groundwater and surface water is relied upon as a primary source of water. So anyway, it kicks us into a higher category. I don't know if it's worth pushing back on. We can talk about that process anyway. I
Yeah.
just had a question, and maybe this is an area we could look at a little bit more closely if we wanted to.
Yeah, and that was really why I wanted to present this, so you guys could see what went into it, and then it's probably starting the wheels turning about.
I think historically, Casitas has supplied about 30%
Agreed.
of the water over the basin.
Yes.
Or in the valley.
If we use anything more than 4,435 acre feet of groundwater, we're at priority 0.5. If we're less than 4,435, which we typically are in the 3s and 3,500s,
You're only
this could go down to a 4.
Yeah, that's all
You
you
did
can
the
get
math
to
already.
is a 4.
Yeah, yeah.
Geologist
Jordan did the math
math.
already.
Geologist math.
Yeah.
Okay.
So,
Yeah, no, I agree. You can only get down to a 4.
Right. So keep that in mind when we get to the totals, and you'll see where
See
it
what
is
one
between a
point-
medium and a high priority. Okay, then the degree to which groundwater is relied upon as a primary source of water is the second part of component 6. And again, there's a lot of data sources that were used. There's a lot of calculations that were involved. I did not get into the weeds on all of it, but I just wanted you to see that it was kind of an involved process. What that ended up with is kind of what Richard was saying. The percent of groundwater in the Ojai Valley, the dependency is about 63% for both ag and urban uses. And the rest is, supplemented by casitas. So because of that dependency, that 63%, again, puts us into one of the higher priority point categories with a score of 4. So to get the total points for component 6, you take the average of the previous two. So we had one that was a 5 and one that was a 4. The average is 4.5 for component 6. Okay, then there's a bunch of other factors: overdraft, subsidence, saline intrusion, or other water quality degradation. This slide shows the maximum points for each of those. Declining groundwater levels, 7.5 points. If there's current inelastic subsidence, it was 10 points. If there was historical subsidence, 3 points. You can see the points for saline intrusion or for water quality that exceeds MCL, which stands for maximum contaminant level. Can range from 1 to 3 points. So I'll walk through each of these. This one I found interesting. The declining groundwater level, Ojai got the full 7.5 points for that. And there was I should have made this larger, but there was a note in the spreadsheet that I thought you might be interested in. Again, they were doing this in 2019, right? So they had this data from 2013 that the water elevation in the Key Well, blah, blah, it was down 50.2 feet from the 2013 measurement after having been down 78.4 feet from the 2012 measurement. The Ojai Valley Basin responds quickly to rainfall or the lack of rainfall, and it's not uncommon to see large drops in water level during dry periods and recovery to at or above normal levels during wet periods. So they're acknowledging the way the basin behaves. Droughts have a significant impact, and high storm events have a bounce back effect. I couldn't find the hydrograph that they reference in Appendix B. I tried searching for this document and I was not successful. So we did get that 7.5 score for the groundwater level decline because of the nature of it.
Julia, is that second sentence correct? No indication of full recovery from dry periods. I'm looking at nothing but full recovery. from dry
Again,
periods, and that
today,
seems
yes,
that
that's true.
well, I mean, over the last 30 years I've been here, it's been
That-
like a yo-yo.
That was where, then they referenced note 2, and that's what this note 2 down at the bottom is. So, again, that might be something we could question, with DWR staff, if there's a longer historical record to point to. I really wanted to try to find that hydrograph, but like I said, I wasn't successful.
Do you want it?
Sure. Okay. Subsidence, 0. Probably saw that coming.
Thank God.
Saline intrusion, 0. Okay, water quality degradation. That one was not 0. So this one, again, was a little bit of an involved process where they looked at both the magnitude and the prevalence of water quality degradation. So I'll walk through each of those. So in the first one, the magnitude, they looked at exceedances of the maximum contaminant level in a lot of different constituents. Again, I don't have the backup for all of the water quality data because there is so much water quality data, but there were a number of exceedances, and they calculated the average relative MCL exceedance. The way they did some math in the background was if a water quality parameter was double the MCL, they gave it a score of 2. So when all that was said and done, again, there were a number of water quality exceedances and ended up with a maximum priority points of 5 in this category.
Regardless of whether it's naturally occurring or contamination.
I didn't find anything to indicate what was taken into account.
What year?
Um,
What's the base?
Let me look. I know that they had a range of years in here. It was data with between January 1st of 2000 and April 4th of 2017. And they used the State Water Resources Control Board GeoTracker, which is what agencies have to report their water quality through. Then that was the magnitude. Then the prevalence was dividing the number of unique wells that had an exceedance by the number of public water supply wells within the basin. So there were 8 unique wells that exceeded the MCL during that period, and there were 8 public wells, supply wells. It doesn't say that those exceedances came from those wells. So the 8 divided by 8 is 1, so that yields a priority point score of 4. And then you add those 2 components, the magnitude and the prevalence. So there was a 5 and a 4. Our total score is 9. We got the maximum priority points for that, for water quality degradation. Okay, and then, that was just for 7D, groundwater contamination. Then to add everything, it was 7A, B, C, and D. Everything added up from declining groundwater levels, subsidence, saline intrusion, and water quality. So the 7.5 for groundwater levels, 0 and 0 for subsidence and saline intrusion, and the 3 for water quality yields 10.5 for overall water quality degradation. That landed us at priority points of 2 for the overall score for number 7. Then there was another sort of more subjective, I guess, category of any other relevant information, including impacts to local habitat and stream flows. These were just yes or no. You get 0 points for no and 1 point for yes. So they did find vegetation and wetlands polygons. So Ojai was given 1s for each of those, for both vegetation and This one, Jordan, I don't know if you want to chime in. They use the NHD dataset to determine if one or more perennial or permanent streams are located within or adjacent to the basin. Is that,
I think that's accurate. I mean, there are technically parts of San Antonio Creek are listed as perennial.
yep, okay. So we got full points for that. Then any other information that was determined to be relevant by the department could have included like unique hydrology or geology or land use factors or any other challenges. OHI didn't have any of those unique things, so a 0 was assigned for that. Then these are some other conditions that were included for subcomponent A, C, and D. Based on how much is extracted out of the basin, we fell within this category that's in bold, between 2,000 and 9,500 acre feet for water year 2014 with no documented impacts. So we got a score of 0 for that. My mouse is lagging. There you go. Okay, so then add up all of those 8 criteria. Population density was a 2, projected population change 0, public supply wells and production wells were both a 4, the irrigated acreage density was a 4, the dependency of the basin on groundwater for total water supply was a 4.5. All of those other water quality factors were a 2, habitat and stream flow was a 2, our total score is 22.5. This is where the very low, low, medium, and high points are distributed. So at 22.5, land, right in the low end of the high category. It would take a lot to get to low, to get to a 14. So even if we questioned any of the scores, we're talking 1 or 2.
How about to medium? Would that have any effect?
Medium, we'd still be subject to all of the sigma requirements, as Peter mentioned the last time. It wouldn't really gain us anything.
Because just the quick calculation, if you increase the public wells, which would be more accurate to the reality, you could get to medium possibly.
Yeah.
You could get to medium.
You could get to medium.
But if
Yeah.
there's no impact, why?
Yeah.
Because there was a
May-
couple
if
places
the-
where it was close.
Yeah, I mean, maybe if legislation changes and mediums have different requirements at some point down the road, maybe that's a worthwhile exercise.
We get more people to leave and more fallow ag land.
No,
Reduce,
You're already getting
reduce the irrigated
Arguably,
acreage.
you're already there.
Yeah,
I mean, that's, that number 5 point component, just kind of running down the math, you could easily reduce that by 1 point.
yeah, there's,
But just with a 20% reduction that we've seen. So, I mean, that'd be, pardon the pun, low-hanging fruit to pull as would the argument of a groundwater level decline being consistent and forever
Yeah.
heading south.
you get a half point off of the one, and I think you might get 2 off of 2 of those others.
Could you get to medium? Maybe.
If it's relevant. On the water quality,
yes.
where are we? I didn't see, if it says 1,031, I don't really have a relevance of, is that extreme? Is that the top? Is it the 40
That's how many
percentile? Oh, I know that.
data sets that they took.
Well, I know
looked
that,
at.
but
Okay.
where is it relative to the water quality being, very poor? I mean, where are we on the cusp? Are we at the 40th percentile? Are we half? Are we 60%?
Well, so
It's
Casitas
not
puts
like your
out
miners-
their annual water quality report.
Okay.
And I don't know about the other smaller agencies, if they're required to or not. You guys do your own testing and all of that, right, on your wells? Our water quality's always been really good. So, like I said, I don't know where those MCL exceedances were. I don't know for what water quality components they were, what levels they were, how bad they were. I would need to get all of that information from DWR.
Can we get that from them?
I can certainly ask. Yeah.
I think people would be pretty interested in the water quality.
But they get it.
I mean, they get, yeah, we mail out the annual water quality report to
Why
every
don't you ask her?
homeowner.
Yeah, because, I mean, everybody gets it. Nowadays, you just get the link. You don't get the report.
Right, it's on our website,
Yes.
On our website.
Is this,
on Casitas's website, I'm sorry.
All
Casitas's,
purveyors
forgot who was,
Get it from
all the
City of
purveyors, yes.
Julia,
Ventura's.
is this potable water quality standards or?
Yes,
Oh,
yes, EPA.
Even though probably for agriculture, you would need to be at that
If
time.
it's drinking water, then it
I understand.
should be, but if it's
But
just
a
for
lot of our-
irrigation, then,
Our
yeah,
water use is not drinking water.
right.
They don't distinguish.
That's a great question, and I don't know the answer. I mean, if you're just a farmer using it for irrigation, you're probably not, I don't know, are you reporting your water quality to the state?
Only to food safety sources.
Okay, so I didn't see that being a data source that they used. So I'm just gonna assume it was all the publicly available water quality information from the purveyors.
If they use
And it-
GeoTracker, then it might be more.
It might be more.
It might be a high nitrate concentration from a well that's not domestically or used for drinking water. It could be a high salinity well that was reported to some database on the state at some point. And that's the problem with using GeoTracker as a blanket catch-all, cover-all for water quality, because while it may be representative of portions of the basin at snapshots in time, it's not necessarily reflective of the health of the basin as a whole.
Yeah.
I would rely on the annual water quality reports that are sent out to every customer,
I guess
or the link.
these are the issues that are gonna have to be addressed in these 5-year, $250,000 reports. We're gonna have to start ticking off some of these things and getting them off the table, because they're not a problem for us. And
I see what you're saying.
I don't know how we structure that. It seems to me we ought to be able to go through and say, subsidence is not a problem, we don't have to talk about it anymore. Seawater intrusion, don't have to talk about it anymore. And if we could tackle quality, we may be able to knock that one off.
Mm-hmm,
So,
okay.
I think you could do that just by delineating the difference in the wells. I have a number of people who've got terrible wells, but they only use them, high nitrates, they only use them for the irrigation. And if those are counted as a well, and the water's not potable at all.
well, you can't deliver water for drinking water if it exceeds the MCL for nitrogen.
Right.
So, no one's doing that as
Right.
far as I can tell.
You'd have to notify them, and
Yeah.
you'd get,
Yeah.
Division of Drinking Water would be very upset with you.
Well, I think, yes, so the 8 that we're counting are probably drinking water wells, but not the rest of the 163 that are out there.
Those 8 were probably, as I'm thinking about it, they were Golden State wells at the time, because Casitas didn't own them yet.
But they were under the same requirements.
Right, yeah, yeah. Okay. It was an interesting exercise for me to go through and read this, and I appreciate, I don't know if she's on anymore, but Nancy Ojeda from DWR was the one who supplied me with this and the spreadsheet showing how it was all calculated.
Any other questions?
Great.
Thank you, Julia, that was really informative. Any questions from the public? Okay, hearing none, we are adjourned at 4:04.
Thank you. Great report.
Yeah, thanks, somebody.
Could
Yeah, thanks.
you
thanks.
email that?
Yeah, I'd be happy to.
That one-
I'll PDF it and send it
Yeah.
out to you guys.
That would be great.
The thing that's interesting is how
Signing
much
off.
of
You
that
guys all have a good
data
afternoon.
is similar to the flow data that